Hello again, this is Mr. V. Hill. Today we're going to be talking about the basics of exponents. And the first thing we're going to be doing with exponents is basically simplifying exponential expressions. And just to remind ourselves what simplifying means, I've got it written here, it means to do all the arithmetic that you can. And now that we have variables and whatnot put into our expressions, we're going to include the distributive property as a bit of arithmetic that we can do, meaning that if we have a factor times a sum, we can distribute that factor into the sum. We can do that multiplication now. We also want to combine like terms, meaning we can do this addition now, and we want to combine like factors in this way. So, with exponents, we're also going to throw in a few more things. Basically, we can't have any parentheses in our expression. Parentheses in there means it's not simplified yet. It means we can still do some arithmetic. Normally, we would deal with that with the distributive property, but now with exponents, there are some other tricks that we can apply. Also, we don't want any fractions within fractions. That still holds, but I just want to remind you because they're going to come up a lot more now in exponential expressions. But remember, that's easy to deal with because division is actually multiplying by the reciprocal. So we can change this division into a multiplication problem, and then we can actually do this multiplication, numerator times numerator, denominator times denominator, and then we're done with that. Also, no negative exponents. For instance, if we have x to the power of negative 2, way back when, we defined that to be 1 over x squared. So we can't have any negative exponents in our expressions either. Now, just to remind everyone, the big reasons why all of our exponent rules that we're going to be learning work is basically because of this picture that we should all remember putting in our notes. This hierarchy of operations. The base operation is addition. We don't need subtraction anymore because subtraction is just adding a negative. Above that is multiplication because a multiplication is nothing more than a repeated addition. And since multiplication is a repeated addition, it distributes over addition. Remember the distributive property here. Now we don't need any division because division is really just multiplying by the reciprocal, like we just looked at right here. Above multiplication come our exponents, and exponents come above multiplication because exponents are repeated multiplication, and for that reason exponents end up distributing over multiplication. So, once again, this picture is extremely important to understand. Now, first thing we need to see are zero and negative exponents. We've kind of talked about this before, but we haven't really explained why they are what they are yet. But of course, if the base of the exponential is not 0, if we raise that number to the power of 0, that is going to be equal to 1. For a negative exponent, if n is a positive integer, actually really any positive real number, a to the power of negative n is equal to 1 over a to the n. Okay. We talked about that before, but now we want to see why that happens. So if we look at an exponential function, or even a pattern like when we looked at the very beginning of the year when n was just natural numbers or whole numbers, well, an exponent of 1 just means we take one of those things and multiply them together. So 3 to the first is 3. 2, if n is 2, 3 squared is 9, of course. And we just see how this pattern goes. Going this direction, we just keep multiplying by another factor of 3. So in order to figure out what an exponent of 0 means, well, we just follow this pattern backwards. So to get from 81 to 27, we divide by 3. To get from 27 to 9, we divide by 3. To get from 9 to 3, we divide by 3. So it would make sense that going backwards, we're going to do the same thing. We divide by 3 again, and so an exponent of 0 has to equal, well, 3 divided by 3 is 1. And now the patterns will still hold. 1 times 3 is 3, 3 times 3 is 9, so on and so forth. Still keeps working. Going back one more, if we divide by 3 again in this direction, we see that 3 to the power of negative 1 is equal to 1/3. We just divide this 1 by 3, and there we go. Going back again, following the same pattern. We see that 3 to the power of negative 2, well, we divide 1/3 by 3. 1/3 divided by 3 is, of course, 1/9. But since 9 is 3 squared, we could rewrite it that way, 1 over 3 squared. I mean, the simplified version would be 1/9, but we see that this exponent of negative 2 becomes an exponent of positive 2 in the denominator. We'll look at this some more. There's other reasons why these negative exponents have to be what they are and why a zero exponent has to be what it is. But for right now, this table should convince you that that's what they are. Now, what we really want to do is simplify these exponential expressions. So we're just going to work through an example here. We have 2x over y is all being raised to the power of negative 2. And there's a number of different ways of going about this, and no one way is more correct than another. But first thing we might want to do is look at this exponent of negative 2. Remember that this is going to now be equal to, by the definition of a negative exponent, 1 over this thing, 2x over y, raised to the power of positive 2. Because that's just how negative exponents work. A negative exponent means we take 1 over the thing and raise it to a positive exponent. Now we're going to learn some other tricks on how to deal with this in the denominator in a little while, but for right now, let's just say that, well, we know what squaring means. A power of 2 means we take 2 of those things and multiply them together. So we have 1 over 2x over y times 2x over y. Okay. Now we're just going to keep doing all the arithmetic that we can. We know how to multiply these two factors together on the bottom. We multiply numerator times numerator and denominator times denominator. So this thing is going to be equal to 1 over 2x times 2x. There's our two numerators. And y times y. Those are our denominators multiplied together. Let's bring this up here. And so now we just continue doing these multiplications. Right? We combine the like factors here, and I'll put parentheses around this whole denominator. So we have 1 over 2 times 2 is, of course, 4. X times x is x squared. And y times y is y squared. Now remember, now unfortunately we have a fraction within a fraction. We don't want that. That's not simplified. But that's easy to deal with because dividing by something is the same thing as multiplying by its reciprocal. So this is 1 times the reciprocal of this denominator, y squared over 4x squared. And of course, we multiplying by 1 doesn't do anything, so the whole thing is just y squared over 4x squared. Not that difficult. And so, I'm going to leave you with a couple of practice problems. So simplify these two expressions. Now, of course, you're going to assume that your variables involved in here are not 0, so that we can actually apply the definitions of 0 exponents and negative exponents. So do those now and have them ready for class. Thanks for watching.